Okay, so this is a bit of a test. My other microphone had broken, so I'm just using the built-in phone microphone for this one. So that's why it sounds different. So I've got on the screen here the circuit that will go along with the pulse width modulation portion of this course. So I'm going to just go ahead and get rid of this button that we don't actually need. It's left over from another thing. And I'm going to go on and connect my Arduino to power. That has all been plugged in. So actually this is already set up because I was doing some testing. Let me hide that just to make sure that it's actually working how I intended it to. Okay, it is. So let's do some stuff. Let's actually just disconnect all the bits and we'll build this from start. Okay, for the most part. Okay, so I've got my breadboard here. Again, we're gonna be connecting both sides to power and ground. That's just gonna be a default on all of mine. As well as, at some point we're gonna have to connect to the positive and the negative, so I just left those wires in there. I've got the LED that I was using before. This one's a little bent up on the leads, but we'll get the idea across. So what I'm gonna do is I'm gonna go ahead and just plug this in wherever we wanna go. And then it's gotta go through the 220 ohm resistor. So I'm gonna connect that to the negative end. Just double checking my ends there, and that will go to ground. Just like so. The positive end is going to connect, to the positive end of the LED, and just slide that right in there. And that will go to pin number 10 on the Arduino. If you remember that from the code portion, pin number 10 on the Arduino. So that is plugged in right there. That's the first part, and again, we're just going to be turning this off and on, actually incredibly fast, but we'll go from there. So what I'll do is I'll connect the whole Arduino to power just so we can see that yes, there is actually power going through the system. So power and ground. You can see that now it's starting to light up, but it's a little random, and if I just connected it directly to the power, it would just be on all the time. So we're gonna work with this a bit. So let me just plug that back in. I need to get some new jumper wires. These have been used a bit. And we'll plug this one back into pin number, actually I'll leave that off for a second. Next I've got the potentiometer. I'm not gonna break down exactly what it is, how it works. I did that a bit more with the analog video. But just the short version is you turn the knob, the resistor value of the component changes. We connect the outside to positive and ground. It doesn't matter which one is which, so you can flip it around to change the rotation direction. But the middle one is gonna be the one that we measure the electricity coming off of. So I'm gonna plug this in. I've already got the positive and negative right here, already lined up. But if not, you would have to do that. So I'm gonna plug that right there and then take my my wire that connects to pin A0 on the Arduino. You can kind of see it there, A0, that yellow one, and I'm going to connect it to the middle pin of the potentiometer. I think I've got that in there correctly. So all that's left is now reconnect that LED back to pin number 10 on the board. So we now have a light that is on, kind of. What is happening is, if you remember back from when we looked at the numerical value of the LED, we are turning it on and off incredibly fast, faster than the human eye can see. And the way the code is working is it's looking at the voltage coming in from this potentiometer, and as that decreases, we are decreasing the amount of time that the light spins on versus what we spin it as off. we're decreasing that duty cycle, which makes the light seem dimmer. Again, so we're technically turning it on and off, but it's happening so fast that the human brain can't perceive it, and that is just how we see it instead, as the LED changing in brightness as this turns. There may be a point where it only gets so bright. That's fine. That's just limitations of the Arduino and the resistors and the LED. So you play around and find different values, but there may be a point where it seems to kind of max out. You could also map the values in the code a little bit different, but this way we can decide on the brightness of that light, and we can have it respond to different scenarios. If you remember before, I had a photoresistor hooked up, but this time I'm going to work with a pressure sensor instead, just to mix it up. So instead of the potentiometer here, I'm going to pull that out, and I'm going to, right now the LED is going a bit nuts just because the circuit isn't complete, but I am going to instead add in that second resistor and the get over there, and there we are, and the kind of little breakout. So now we should just be able to squeeze this little circle and see the light get brighter. So let's try it. It's kind of hard to see exactly how hard I'm squeezing. And remember, again, it's not necessarily linear, so having very subtle touches are doing a lot at the beginning, but then squeezing between here and squeezing much harder doesn't get as drastic of a change. So again, this has some really cool applications of it, but with these particular components, it may seem a little limited. So I would recommend experimenting and seeing what sensors work better with different situations. I've already you mentioned a bit about the limitations of the photoresistors, but this is another fun one. Now that this is set up, I can just put this in here, and we can see that as I cover it, it gets a lot dimmer. There's still a lot of light in this room, but as we open it up, it gets brighter. And again, you can play around with whatever sensors you may have in your kit. They usually come with a handful of them. You can play around with different components instead of LEDs. Sometimes they'll have other components like motors and things that will work. I'm actually going to try on the fly this particular one right here. If I can get the pins in the hole. Get in there. Gosh. Then you go to ground, and then you go to what is this? A0, I believe. So let's just make my life a little easier, and we'll just jump it from over there. So we should see maybe. I don't know, but just we can experiment. This is a distance sensor, so it's supposed to be able to tell the distance between things in front of it and adjust the brightness. Maybe I'm missing a part. I just kind of tried this on the fly, so I don't know what if I did it like this with that built-in resistor. Would that maybe work if I move it closer to the ground? There's some fluctuation there. I would need to experiment more with this. I just tried it on the fly because that was the first component that I hadn't used already that I grabbed out of my box. But again, you can explore, try different things, see what works really cool. Again, the creating of the pulse width modulation circuits are essentially identical to the analog circuits, only we have to specifically use the pulse width modulation pins on the board. And if I was to rotate this and kind of bring it up, let's see if I can adjust any of that focus, maybe. But you'll notice that this is the wrong side of the board, first of all. but you'll notice, and yes, I know it's upside down, my cable is only so long, but some of them have these little squiggly marks next to the board number, and this will appear depending on your board, sometimes on the headers, but definitely printed on the board itself. But any of these with the little squiggly marks next to them, those are the ones capable of doing pulse width modulation. Anything else, this won't work on. It has to be one of these little squiggly marked pins in order to use the pulse width. And that's why I put mine on pin number 10. All right, so that's just about it. I'm gonna end it here and combine this with the code video in order to have one cohesive lesson left. There is one more lesson to go through, and that's a bit more of a complicated one. So I'm going to try to get these 3 all ready and up to go in their completed version, and then I will work on that longer one, but that may be a winter break kind of project. We will see. I need to make sure all of my code is updated and things of that nature. So that'll be where I end it for today. Thank you all, and I will see you all the next time that I see you. Bye.